Hello, it's Chandler Klebs, and today I have a very exciting video to record. I've been getting back into programming recently, and I believe I uploaded the video of my JavaScript Powers of 2 program. Now that's very cool. However, I have been trying to relearn C and C++ recently. Years ago, I was apparently pretty good at C, actually very good at C, and I know only a little bit about C++. I know that it's 90% the same as C, but that it has classes and all these advanced features that I haven't learned how to use. And I have the first edition of the C programming language. I read this book, and I also have the second edition of the C++ programming language. And while these are good, they're heavily out of date. So I've had to look at the online resources. There's several websites that have references. I basically am just Googling the names of functions that I remember. Particularly, what I've had the hardest time figuring out has been dynamic memory allocation, which technically isn't required, but rather than just statically allocating a set size in my programs, I'm trying to make sure that I learn now how to allocate memory dynamically. And so that means in C using malloc and free, and in C++ using new and delete. I like the C++ way better. It just seems cleaner. So I'm going to show you how I compile my C++ programs. Okay, so I'm going to switch to my screen, and I have MSys2 installed here. And basically, I have these shortcuts. When I run this file here, it opens me up into a really cool terminal. And you'll see here, it's like Linux, basically. And I have different folders. The games folder actually doesn't have anything in it yet. I have my C folder on my C++ folder. So I'm going to switch to the CPP folder. And you'll see here, okay, I have some weird stuff here. Now what I'm going to do, this shortcut will take me to this folder. So I can view it in my Windows File Explorer where this is. And if I go here now, see these executable files, I actually don't need that stuff. All that's relevant here is the source code. And within each of these source files, actually that comment's weird. That's weird how that was. Yeah. Okay. Yeah, that was just a little bit strange. Wait a minute. Why is this comment here? This is not a Powers of 2 program. This is a Hello World program. Okay, I'm just going to delete that comment. Anyway, this is hello.cpp, and this is the command that will compile and run it. Okay, so let me go back to my terminal, and I'm going to make this bigger. So you'll see if I just do G++, it'll say there's no input files. However, if I paste in this command that I just copied, then it tries to compile it. Oh, wait. Oh, that's right. I see what's wrong. Oh, I made a mistake here. On Linux, you have to do the // and then the name of the program that you're trying to run. Now remember, MSys is it's like a Unix or Linux type of environment. It's not an emulator. It's all Windows programs. It runs on Windows, but it compiles in a similar environment. People who look at MSys online, just Google it. They'll know what I'm talking about. Okay, so I'm going to do this again here, and it displays Hello World. Okay, so that's the thing, is it works. Now I'm going to show you something else. I'm going to go to, yes, I want to save that because I fixed some errors there. Now over here, this is my Powers of 2 program. And this is a little bit complicated compared to a lot of the other things I've done. So there's the command. The only difference is the name of the file here. Oops, wrong window. That is my recording software. Okay, so now I'm going to compile and run the Powers of 2 program. And see what it did there? What it's doing is it's displaying 32 number digits here, basically. And there's a reason for that. Everything this program does is fully customizable. It displays the first 32 powers of 2, like basically up to 2 to the 32nd power. And you'll see why. The source code explains everything. If I set the length to 64, that's how many digits it will use. And the length variable is how much memory it tries to allocate for the array. The array's name is A, and this is actually a pointer. This is kind of like the official way of allocating memory. So now now that I changed it to 64, I'm going to run it again. See how that works? See how now it's twice as wide? That's because the length variable determines how wide it is. Technically, the length can get up into thousands or even millions of digits. However, I can probably only fit a certain amount on the screen. So like if I were to do like say 128, it probably would not even fit on the screen. Actually, it does. That's actually impressive. Let's try 256. Notice that the numbers I'm using are themselves powers of 2. I'm obsessed with powers of 2. See, and now it's too wide for the screen, so that it doesn't work. So anyway, I'm going to set this back to its default of 32. And then what you'll notice here is this number here, this is the looping decider. Basically, this Z variable, all it does is make the big loop execute multiple times. If I were to set this to 64, then it will go as far as 2 to the 64th power. You see that? 1-844-6744-0737-095-1616. So basically, I can scroll through the output here. So it displays starting at 1. The extra zeros are there for a reason, to help line up all the place values. So I can view the powers of 2 in perfect accuracy. Now, I've sort of described in my JavaScript video how the program actually works, but for those who haven't seen that video, I really want to explain how this program works because it's very cleverly done. I wrote this same thing in QBasic years ago. Okay, basically, take a deep breath. This is going to take a little while to explain. So basically, the length number is, I've already explained that part, and it dynamically allocates memory. You need to understand about integer variables and pointers in C++ to understand exactly the details of why this works. So that's implementation details as far as how the memory is allocated. So once you get past all that, the variables x, y, and z are declared here. They could be named anything, but the comment right there explains why I use those, because like the XYZ coordinates in Minecraft. And actually, this has nothing to do with coordinates, but I just like those letters of the alphabet because they're at the end. Okay, so this loop runs 64 times the way I have it set. And here's what it's doing. Each time it runs a loop, this loop goes from the end of the array. So basically starting at the right, the highest element, length minus 1, and then while it's greater than or equal to 0, it runs this loop, and each time x goes down by 1. And the effect this has is that it basically displays them starting from descending order. Like I could make it go the other way, but everything would be backwards. But basically, it's just looping through. All this line here does is it loops through the entire array and just displays to standard output that particular element, the X element of the A array. And then another cout statement to output a new line. And so that's all it does. After it's displayed all the digits, then it does a new line, just as you can see in the output there. So that's what it's doing. That's all it's doing as far as output. So the only thing that's complicated in here, and what most new programmers may not understand, is how the math is performed. Okay, so basically it's going through the array starting at the bottom, and then it's working its way up. X is increasing through each part of the loop. And so basically they're accessed as digits. So it doubles the number with a binary left shift, same as adding it to itself. And y, which starts at 0, is the carry variable. And it will be either 0 or 1 through this whole program. Basically, it's the same as if you are adding the numbers on paper and then keeping track of the carry. So the line here is where all of the action of this particular loop takes place. Most of the action anyway. So if the X element of A is greater than 9, then it sets the carry to 1. And that will mean on the next digit it will add 1 to that digit. Okay, and then it subtracts 10 from that digit to make sure that it stays a single digit and we don't end up with more digits than we should have. And then otherwise, if that part doesn't execute because it's less than 9, then the carry will become 0. So if you understand how addition is done on paper, the way you just do addition math in decimal form, you'll understand that my program here is doing the exact same thing. So hopefully you understand that. And experienced programmers probably will understand that, but I'm just trying to explain it as clearly as I can. So then after it does all that, it's displayed everything, it's done all that math, then it deletes the array basically deallocates the memory that it allocated earlier, and then returns 0, the standard exit from a program. So that's it. The program does all that, and then it ends. So it's actually very impressive that it works. The thing is, now the program, it looks kind of big. It's really not that big. It's just that now not all the code actually fits on the screen at one time. I probably could optimize it. The only trouble is that it could get very strange. Yeah, well, that's something I can do outside of recording a video. I either need to reduce the size of the font, or I would need to, if I wanted to all fit on one side part of the screen, I would have to just remove some extra lines somehow. Well, anyway, I really hope that the way this program works makes sense. I know I got one Facebook comment. They were asking about how this program worked, basically, because they saw the output and and it looked a little mysterious. So anyway, I think that explains that. Anyway, I'm very excited to get back into programming because it can be a lot of fun to do my integer sequence programs, and I have another one in mind that I'll work on when I find the time. So anyway, I hope you enjoy this video, you nerds out there who actually care about the powers of 2.